Okay, these questions are asking us about the domain of various functions. And the key thing with domain is you're looking for where the function has valid values. What input values for x give you regular outputs, right? So, in 31 here, right, this becomes this. You get issues in a rational function like this when the denominator is 0. Right, so what we're interested in is finding when x squared minus 9 equals 0, which would be x equals plus or minus 3. So at this point, we would get 1 over 0 problems. So we know that our domain, everywhere else is fine. So our domain is x in the reals such that x does not equal plus or minus 3. Right, that's one way of writing it. Or it could be, you could write it as the set of reals without the numbers minus 3 or plus 3. Or you could write it as the minus infinity to minus 3 union minus 3 to 3 union 3 to infinity. Right, lots of different ways to write these domains. They're all equivalent. Okay, question 32, similar. Right, we're interested in when the denominator is 0. X squared plus x minus 6 equals 0. We want to factorize that. Factorize x plus 3x minus 2. So x equals 2 or negative 3. Those are the points that we don't have a valid denominator or don't have a valid frac function. So our domain is the rest of the reals. Okay, so the next one. F of t equals the cube root of 2t minus 1. Now, this is actually a bit of a boring problem, right? Cube roots are always valid. You can take the cube root of positive, negative, 0. So there's no t values that will give you an issue. So for 33, our domain is t is in the reals. All the reals. 34 on the other hand, let's copy that down. G of 3 minus t, 2 plus t. Right, square roots for real values give us an issue when you try and take square root of a negative. Right? So we get an issue when 3 minus t is less than 0. Right? We also get an issue when 2 plus t is less than 0. So we'll take these two inequalities and see what they give us. Right? Okay, first one, obviously, t greater than 3 is going to give us an issue. And t less than negative 2 is going to give us an issue. So we don't get a problem when t is greater than negative 2 or less than 3. So that's our domain. Right? To write that as our inset notation, our domain is t in the reals such that negative 2 is less than t is less than 3. We could write as an interval, -2